Howdy, everyone. It's me again, Parker G, your SI leader, and I'm hope y'all are having a good week. Today, we're going to be going over some SP5 questions. So, um, some of these were a little bit difficult to get through, so we're just going to run through them a bit. Question 7 says, sketch the graph of three different lines whose slope are positive, negative, and zero. We've already sketched some graphs, so we're just going to go ahead and look at the graphs to see if they are positive, negative, or zero. So this first graph, to have a positive slope, we need both a rise and run to be positive. Well, on this one, we can see we have 2 points. So if we rise 1, we rose 2, and then we're going to run 3, right? So our slope is going to be 2 over 3. That's positive, right? So that's how we know we have a positive slope. Well, what happens if it's the opposite? Well, I drew up another graph, and we are going to rise, but in the negative direction. So 1, 2, and then we're going to run 1. So the slope of this one is negative 2 over 1, or just negative 2. So that's the difference between the positive or negative. So in our slope, or mathematically, a positive slope is, of course, going to be positive, and then a negative is going to be negative. Where it gets a little bit tricky is a zero slope. So what we can do here is, well, let's see if it rises and runs, right? Well, this one, it doesn't rise any, right? So rises 0. And then it's not really, it is running, but it's running forever. But we can just choose some slope, some points, right? And so let's just say it ran 3. 0 over 3 is just 0. So that's how we know that our slope is 0. Or it's a horizontal line. That also represents a 0 slope. So m is equal to 0. The reason why it's tricky is because we can also have a vertical line. Well, a cool trick is we all know, like, you can't divide by 0, and it's a little bit difficult to understand why you can't divide by 0. But mathematically, if we again do our rise and run, and we are rising infinite again, just like we were running infinite. So let's just say we are rising 2, but we're not running at all. So that's dividing by 0. So that's why we get a undefined slope, or just one that's straight up and down, because we're dividing by 0. So this is slope of 0, and then this one is undefined, right? So next, we're going to go to question 15. Question 15 says, find the slope of a line through points -1, 4, and 5, 2. And then we want to do this using both the slope formula and using the graph. Well, I've got a graph set up for us. So let's just do the slope formula first. You could do either one first, but I'm just going to go ahead and do the slope one first. So we're going to graph these. Remember, this is x and y. So -1, 4. Well, -1, and we go up 4. So there's one of our points. And then we have 5, 2. Again, this is x and y. We're going to go 1, 2, 3, 4, 5. And then we're going to go up 2. 1, 2. So those are our 2 points. And we can just, since it is a line, we can connect the 2. So just like we did up here and found these slopes, we can find it just by doing rise and run. So I bet y'all are getting the hang of it and can tell that this is going to be a negative slope just because it's pointing down, right? So if we rise -2, And then we're running 1, 2, 3, 4, 5, 6. Running 6. So that means that our slope is going to be m is equal to, well, let's simplify this fraction. 2 goes into 6 3 times, so it's just going to be negative 1/3. Our slope is negative 1/3. Right? Now we can do the slope formula. Well, our slope formula is going to be m is equal to y2 minus y1 over x2 minus x1. So we can choose an x1 and x2. I like to just choose x1 to be the one that is furthest to the left or the smaller number. So that would be this one. So I choose negative 1, comma 4 to be x1 and y1. Then 5, comma 2 to be x2 and y2. So now we just have to plug everything in. M is equal to, well, y2 is 2 minus y1 is 4 over x2 is 5 minus x1, which is negative 1. So I'm going to put a parenthesis just to show that those are separate. Now let's simplify. 2 minus 4 is negative 2. And 5 minus negative 1 is really 5 plus 1, which is 6. So that's the same thing that we got over here. So let's just go ahead and simplify it. And that is negative 1/3. No matter which way you do, you get the same answer, right? And so sometimes you're going to have some very neat points like what we have here, and you're going to be able to graph it out. And if you prefer to do it that method, you can go right ahead. And if you have some a little bit more complicated points and it's like 400 and 200, you can't really graph those out. That's a little bit more difficult. So you can just use the slope intercept or the slope formula. All right. So now we're going to move on to question 20. Question 20 says, which of the following pairs of lines are parallel and perpendicular? Well, what does parallel and perpendicular mean? Parallel is two lines that have the same slope, but different x or y intercepts. What about perpendicular? Perpendicular is just going to be negative reciprocals. So reciprocal just sounds like a fancy word, but it's going to be, just write it out for you. Something like that, right? Negative reciprocals. Reciprocals just means flipping the fraction. So if we have a fraction, I'm just going to use some symbols. A over B, it could be like 1/3. Well, that just goes to B over A, which is 3/1. Now we just have negative, right? So if it's positive 1/3 and we do the perpendicular slope, which is a negative reciprocal, it's going to be negative 3/1 or negative 3. So to determine if these are all parallel or perpendicular, all we have to do is look at their slopes, right? So these first two are easy. Slope on this one is we already have it in slope intercept form. So it's just going to be 6. This one is going to be positive 6. So you can kind of start to see that these might be perpendicular because they are flipped and one's negative, right? But these other two make it a little bit more tricky. So let's just go ahead and solve C and D for slope-intercept form. So if we do C down here, we have x plus 6y is equal to 30. We want to get y by itself. So we're going to subtract x. We're left with 6y is equal to, I like to keep my variable first, so I'm just going to keep negative x up front, plus 30. Next, we're going to divide by 6. And we are left with y is equal to negative 1 over 6 times x. And then 30 divided by 6 is 5, plus 5. So what's this slope? Well, it's negative 1/6. Ooh, there's another one. That one might be parallel. They have the same slope. All right. Now we can do the last one. I'm just going to go ahead and move this stuff over. And then we have D. 2x minus 12y is equal to 15. Again, we want to get y by itself. So we're going to subtract 2x from both sides. Get negative 12y is equal to negative 2x plus 15. Now we have to get y by itself, and so we're going to divide by negative 12. Divide by negative 12. And so we're going to get y is equal to negative 2 over 12 negative plus 15 over negative 12. So remember, if we're dividing two terms, you divide them separately. These negatives are going to cancel, right? And then 2 over 12, well, 2 goes into 12 6 times, so it's going to be 1/6. So we're just going to come up here. Y is equal to 1/6. And then 15 over 12, 3 goes into both of them. 3 goes into 15 5 times, and negative 12. So I can move that 12 out, or that negative out, to negative 5 over 4. So our slope was 1/6. Right. So I'm just going to go ahead and erase this work right here because I need a little bit more space to write. Now we can answer the question, which are parallel and which are perpendicular? Well, the ones that's easy is parallel. They're just the exact same slope, but different y-intercepts. So that's going to be A and C, right? So A and C are parallel. What about any other ones? Is any other ones parallel? It doesn't look like it, right? So what about perpendicular? Well, if we want to see if 6 is perpendicular to negative 1/6, we can just do that negative reciprocal. So negative 1/6, we can make it positive, and then we're going to switch these two. So it's going to be 6 over 1. 6 over 1 just equal to 6. So boom, those ones are perpendicular. So B is perpendicular to both A and C. I hope that helped everyone, and thank you so much for watching.